Hello and welcome back to you people. We are entering kind of a new sub-chapter of our review of algebra prior to calculus. So today we're going to be looking at solving different types of equations. So there are many types of equations, as I'm sure you can imagine. So let us start with the first case, linear equations. Linear means line, and line means that these are going to be x to the power of one type of equations, right? So linear means that basically the equation has an x to the 1 in it. I think we all know how to solve this, right? So, but I can tell you in a resume, the idea is to here, so we want to isolate, we want to isolate the variable, which is usually x, right? That's what it means to actually solve the equation. It means to solve for x or isolate what x is. So a very quick example. So example 1, all these are really straightforward. So solve, oh yeah, I prepared something here. Solve 2x minus 7, notice x to the 1, yes, so linear, equal to 5x minus 4. So x to the 1 and x to the 1, both sides have an x to the 1. That's a linear equation. So what does that mean? We need to isolate x. So the idea, of course, behind this is to bring all the x's to the same side. So 2x, and this 5x, which is on the other side, what happens when it moves to the left? It becomes negative. We all know that. We heard a review, but I'll bet that this is something that everybody remembers, right? There's already a minus 4 here, so I'm going to bring the minus 7. I'm going to bring it over there, and it's going to become a plus 7. So 2x minus 5x is minus 3x. Minus 4 plus 7 is 3. And what do we do now? Anybody remembers? Yeah, we divide both sides by negative 3. We divide both sides by negative 3, and we have achieved what we were up to. We want to isolate x. There it is happening right here. And the answer to this is minus 1. It's very easy to check this answer. You're not going to be required to do that, but I'm going to do it here. In the case of a linear equation, we don't necessarily need to check things, but just for the sake of the argument, if I replace x by minus 1 into my original equation, here is what I'm going to get. I'm going to get that minus 2 minus 7 is equal to minus 5 minus 4. In other words, minus 9 is equal to minus 9, which is a true statement, and this actually checks out. All right, so everybody kind of probably remembers this, probably quite well, I would tend to say. So let's actually move on to something a little less trivial. And these are the second class of equation here. So B, we are going to be solving something called quadratic. Quadratic actually means that the equation will involve an x to the power of 2. That's what it means. So quadratic equations, we're going to be looking at two different types of quadratic equations. Okay, so the first one is the one that can be factored. So type 1, factorable. Factorable. So it's one way to solve quadratic equations is whenever the situation lends itself to factoring, it's easier. For example, so this is example 2 for today. We are still, I believe, in the realm of 2.5. So solve for x, and my equation is 5x squared minus 18x minus 8 égale à 0. So notice the presence of an x squared. So that means that we are in the presence of a quadratic equation. Now this actually apparently factors out very nicely. Let's find out how it does. Product and sum. 5 times minus 8, that's minus 40. And the middle number is minus 18. All right, looking for two numbers whose product is minus 40 and whose sum is minus 18. What say you? Shall we say minus 20 and positive 2? For the sum of these two is minus 18 and the product is minus 40. Two numbers are found. That means that I can replace the middle term as I did when we reviewed factoring. We shall replace the minus 18x here by minus 20x plus 2x. And then what do? Well, we factor 2 by 2, those two, and those two. Those guys are to be factored together. So here out with the 5x and x minus 4, and here out with the 2 and x minus 4. We know, remember, that we are successful if we have the same term in the bracket, and we do, so success. We have this. And now we apply the following principle, that if a times b is equal to 0, then what? Either a is 0, or b is 0, or both, right? Then either a is 0 or b is 0. So I'm going to apply this principle here, thinking of this as a, thinking of this as b. So I'm going to be saying x minus 4 is equal to 0, or 5x plus 2 is equal to 0. And we are back to solving a couple of linear equations. Pretty easy. X equals 4, or 5x equals minus 2, and x is minus 2 over 5. These are my two answers. I could check them, but I could use the time on the video in a better way. So I'm going to leave these two answers unchecked. And if you want to check them, be my guest. It's an easy thing to do. Plug them back into the original equation right here. And in both cases, you will obtain 0. If you don't, you made a little calculation mistake. It happens. All right, so that was type 1. Let us take a look at type 2. Well, you've guessed it. If type 1 is factorable, well then type 2 is not factorable. So, exemple numéro 3. So, type 2 is non-factorable. So, maybe something like this. I have an example prepared for you. So, solve the following equation. What do I have here? 2x squared plus 4x plus 1 equal to 0. All right, if you try to factor this, you're going to be looking for two numbers whose product is 1 and whose sum is 4. Yeesh. Product, sorry, did I say product is 1? I meant product is 2, sorry. So product is 2, limited, right? I mean, it's 1 times 2. And 1 plus 2, or 1 minus 2, or 2 minus 1, nothing is going to give me 4. So this is not factorable. You won't be able to factor this at all. So it's still a quadratic equation because it still has a power 2 to the x. So when it's not factorable, here's something that I can try. It's a quadratic equation, and if you remember from high school, we have a quadratic formula. Yes, we do. We do. Quadratic formula. I can hear you from here say, oh no, not this plus again. Well, it's just unavoidable. It's just there in the picture. It will eventually serve us well. We should know what it is. What is it? X is equal to minus b plus or minus the root of b squared minus 4ac over 2a. And what do these guys mean? What's a, what's b, what's c? They all come from ax squared plus bx plus c, and you got to make sure that it's equal to 0. So as you can see, a is the coefficient of x squared, always. B is the coefficient of x, always. And c is the constant, always. So let's take a look at what we have over here. It can't be factored, but maybe the quadratic formula can tell us what the x's are to solve the equation. First, what I'd like to do is extract the values of a and b and c. Because if I do that, then I won't have to think too hard, just plug them into the equation and let it do its magic. So a is the coefficient of x squared, so a is 2. B is the coefficient of x, 4. C is the constant term, 1. So we put those into this equation. So x is equal to minus b plus or minus the root of b squared minus 4 times a times c over 2 times a. So you plug these guys in and then carefully you evaluate them. So minus 4 plus or minus, let's do the square first, so 4 squared is 16. Then let's do the multiplications after that. 4 times 2 times 1 is 8. So that's 4 minus 8 all over 4. All right, I can simplify what's inside the root. 16 minus 8 is just 8. I could leave it like this. I could leave it like this, but I won't because it's not very hard to simplify. But I already see here that I have two answers, right? One with the plus, one with the minus. It's not a coincidence that an equation that has an x2 ends up with two answers. So there's a very fundamental result around that we will probably have a chance to take a look at later. But for now, why don't we try to see if we can simplify this? What is minus 4 plus or minus root 8? How can I write this differently? Well, that's plus or minus 8. I can write as 4 times 2. Can I not? Isn't that 8? 4 times 2? Yes? All right, so now I'm going to use the fact that the root of 4 times 2 is the same as the root of 4 times the root of 2. Why? Simply because the root of 4 is a whole number. It's equal to 2. So that's minus 4 plus or minus 2 root of 2 over 4. So although this is an okay answer, I can take this like 1 degree down and see where that takes me. Question, can I cancel the 4 and the minus 4 here? Yes or no? If you answered no, you're correct, because the minus 4 is linked to its neighbor by a plus or a minus. So there's no direct cancellation here, but there is something that I can do. Brush. I'll do it over here, because I have no more room on this very, 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 very small whiteboard. Minus 4 plus or minus 2 root 2 over 4. So what I want to do here is, I can't cancel the 4 and the minus 4. I can't cancel the 2 and the minus 4 because once again the 2 is linked to the minus 4 by a plus or a minus sign. But perhaps I can take out a 2 from the numerator. Yes? Take out a 2 from minus 4 is minus 2. Take out a 2 from 2 root 2, you are left with root 2 all over 4. And now There's a multiplication between the 2 and the 4. These two can go. And that will give me my two final answers. Two final answers are minus 2 plus or minus root 2 over 2. That is to say that the two answers are one with a plus and the other one with a minus. These are my two answers for this problem that I could not have obtained without the quadratic formula, because it's really the only way to, well, it's not true. There's also completing the square, but we're not going to get into that. Just don't have time. So this is going to be our plan B, our fallback plan whenever we cannot factor. You got to remember this. You got to have that formula on hand. You have it to have handy. And you have to know how to apply it and how to simplify it all the way down to its smallest version. Once again, these are the final answers. Why? Because you cannot cancel these numbers 2 and 2 up, 2 down, because of the plus sign or the minus sign here, right? If you approximate these with your calculator and you plug them back into the original equation, you'll see that they check out. But of course, if you make a little rounding with the root of 2, unless you actually carry 1.4142 that's 16 decimals, you won't get exactly 0 in the end. You're going to get 0.0000007 or something when you check it. Good. All right. So these are quadratic equations. The third type that I would like to talk about today, so C, these are rational equations. So rational equations. Well, rational means ratio. Ratio means fraction. So in here, the x's will actually be part of fractions. The purpose is still the same thing, trying to solve for x at all times. Okay, so to solve for x, will usually involve taking a common denominator. Will usually involve a common denominator. So that's the one tool, denominator. That is the one tool that we are going to keep in mind if we're going to be able to rationalize some of these things and to solve the rational equations. Alors, this is now example 4, I believe. These are a little more challenging, so let's give them 3 stars. So solve the following one. 3 over, I can't read my own handwriting, x plus 1 minus 1 over x minus 1 equals to 4. All right. So rational equations, because the x is part of a ratio, is part of a fraction. So like we said, you know, adding or subtracting fractions usually mean common denominator. So let's do it here. What's going to be the common denominator on the left side? Same thing as usual. Multiply those two guys and do the crisscross. Multiply the two guys and do the crisscross. So 3 times x minus 1, I'm going to use brackets here, just because I want to be careful. Minus 1 times x plus 1. All right. So we've got to find a way to simplify that. So the numerator becomes 3x minus 3 minus x minus 1 over the same thing downstairs, no change. All right, collecting what I can from the numerator, 3x minus x, that's 2x, and minus 3 minus 1, that's minus 4. Again, over x plus 1 and x minus 1, and that's equal to 4. Once you've reached that stage, the one thing that actually works like wonders is to, first of all, keep in mind that 4 is the same as 4 over 1. Now I'm going to do something called cross multiplication. I'm going to multiply this with this, so 2x minus 4 will multiply minus 1, and the 4 will multiply x plus 1, x minus 1. Crisscross, cross multiply. So what I have here is 2x minus 4 times 1. That is going to be equal to 4 times x plus 1, x minus 1. This is my new equation. Now, once we've done this, what do we have? We actually have a quadratic equation. You don't see it yet, you'll see it in a second. So the left-hand side times 1, so it's itself. And here, if I open these brackets up, x plus 1 times x minus 1, this is x squared minus 1. Times 4 will give me 4x squared minus 4. Yeah? You can see the square here. We are back to what we were before, quadratic equation. So I'm going to make that equal to 0. Right? This is how we can apply the quadratic formula. It's got to be equal to 0. Remember, ax squared plus bx plus c is equal to 0 all the time. So that has to be equal to 0. So what do I have? 4x squared. 2x goes on the other side, minus 2x. And minus 4 plus 4 is 0. Now I got to solve something that's actually not too hard. Right? So 0 is equal to take out a 2x. Take out a 2x, and you'll get 2x minus 1. 2x minus 1 means, let me rewrite it over here, 2x times 2x minus 1 égale à 0. Now, product of two things, remember a times b equals 0, that means one or the other are 0, so 2x is equal to 0, or 2x minus 1 is equal to 0, that means 0, and that means 1/2, right? If you check those, you will see that it actually works very well. So I'm going to check only one of them. I don't have time for both. So check x is equal to 0 into always the original equation. So check x is equal to 0 in the original equation. So 3 over 0 plus 1 minus 1 over 0 minus 1. That should be equal to 4. Does it work? Do you see it working? So that's 3 minus 1 equals 4. It works. I will leave the checking of x is equal to 1/2 to your good care. And you will see that it also works on this, no problem. All right, I would like to do another example on this, and that would be, I believe, example 5. Example 5. What's the caliber of this guy? Relatively the same as before. So 3 stars. Solve 5 minus 2x plus 1 over 2x minus 1 equals to 8 over x plus 3. All right. So it's a rational equation simply because the x's are involved in ratios, right? In fractions. So the same idea here will be, as before, to take a common denominator. So we'll remember that 5 is the same as 5 over 1. So on the left, what will I have as a common denominator? 1 times 2x minus 1. Then we crisscross. So 5 times 2x minus 1 minus 2x plus 1. We'll put a bracket here because of the minus in front of the bracket. Egal, the right-hand side, 8 over x plus 3. Good. So let's open the numerator here. That's what? 10x minus 5. And let's open the bracket here as well. Minus 2x minus 1 over 2x minus 1. Can I cancel 2x minus 1 and 2x minus 1 here or there? No, because the top one is linked to its neighbor by a minus sign. Don't do it. Don't do it. So what do I have here? That would be 10x minus 2x is 8x. Minus 5 minus 1 is minus 6. And here we are with this new equation that is equivalent to the other one. What would you do at that stage? What would you do now? Yes, cross multiplication. 8x minus 6 times x plus 3. That is equal to 8 times 2x minus 1. Let's continue this over here. Let us open this bracket. So 8x times x is 8x squared plus 24x minus 6x minus 18. That would be equal to 16x minus 8. What kind of equation do we have here, ladies and gents? What do you recognize here? Oh, it's a square. So another quadratic equation. That's really the theme of today. So everybody on the left, everybody stays on the left. So 8x squared plus 24 minus 6, what would that be? That would be 18x minus 18. And I want to bring what is on the right side, I want to bring that to the left so that I can have an equal to 0. So minus 16x plus 8 equal to 0. Collecting like terms, 8x squared, that is 2x. While this is minus 10. Nice quadratic equation with an x squared. I can make my life a little simpler here if I notice that 8, 2, and 10 are all multiples of 2. So I can take out a 2 and then ask myself what I should be doing now. What do you say? Quadratic equation or factoring? Factoring is faster, but it's not always doable. And if I can't factor, then I can definitely stumble on the quadratic equation. So what do you say? Two numbers whose product is minus 20 and whose sum is 1. Two numbers whose product is minus 20 and whose sum is 1. What about plus 5 and minus 4? Plus 5 and minus 4. 5 times minus 4 is minus 20. 5 minus 4 is 1. That works, right? So plus 5 and minus 4 is going to be the ticket. Plus 5 minus 4 égale à 0. And then I factor 2 by 2. So here comes x, 4x plus 5. Here comes minus 1 because I want a 4x plus 5 as well. So I have the same thing in the bracket there. The final factoring goes to 4x plus 5, x minus 1, égale à 0. And I have three terms, right? So to conclude this, I will say this equal to 0, this equal to 0, this equal to 0. Clearly the first one cannot be equal to 0, so the 2 plays no role in the solution. Or 4x plus 5 is equal to 0, or x minus 1 is equal to 0. So that is 0, that is 0, that is 0. That will give me minus 5 over 4, and that will give me 1. Now clearly it's very possible that on the assignment or on the test the question actually says check your answers, verify your answers. So once again here, I'll make a little bit of space and I will just check one of them. So just for the sake of the argument, I'm going to check 1. So check, we're going to check the answer x equals 1. What does that mean? Well, simple enough. It means plug it back into the original equation. So 5 minus 2 times 1 plus 1 over 2 times 1 minus 1, and that should be equal to 8 over 1 plus 3. Does that work? That's 5 minus 2 times 1 is 2 plus 1 is 3. 2 times 1 is 2 minus 1 is 1. That should be equal to 8 over 1 plus 3. So 5 minus 3 equals to 8 divided by 2. Check. The same thing goes through, holds true, should I say, for the other answer, minus 5 over 4. It's a little longer to check because it's a fraction. So I will leave this to you as a little exercise for you to do. So that's the first half, if you want, of solving equations. We covered the cases of linear, quadratic, and irrational. We still have to look at radical equations, absolute value equations, and perhaps some other cases that are a little bit more random that we'll be doing in the next video. So I hope this was informative. Keep on working well on this, and I will see you very soon. Take care.